Today I'm going to talk about the velocity equation and energy types in simple harmonic motion. First, we discuss about velocity equation and what are the terms in velocity equation. We can write velocity equation like this: v squared equals omega squared into a squared minus x, so a squared minus x squared. Then we talk about the terms in this equation. We always denote the velocity of simple harmonic motion. Omega denote angular velocity and A denote amplitude. Amplitude and X is the most important term. X is displacement from center. We can derive an expression for the maximum velocity. We know that at the center x value is 0. Then our equation becomes v squared equals omega squared into a squared minus 0 squared at the center. Then v squared equals omega squared into a squared. We can take the square root of both sides. Then we get v. I denote this as v maximum. V max equals omega time. To find the maximum velocity of simple harmonic motion, we can use this equation. Or simply we can use this equation to find velocity at any point of the simple harmonic motion. Where this omega comes from? We know that characteristic equation of simple harmonic motion is A equals minus kx. But there is another form of this characteristic equation. It is A equals minus omega squared x. Then k equals to omega squared. If we find the characteristic equation of simple harmonic motion, then we can find this omega. By substituting omega to the equation, we can find velocity of the simple harmonic motion. Next, we're going to talk about the energy of simple harmonic motion. For example, I'm getting simple pendulum. In here, we are going to talk about potential energy, kinetic energy, and total mechanical energy. To talk about the potential energy, first we must define the potential energy zero level. I take this level as potential energy zero level. We know that the potential energy is maximum at the amplitude and the kinetic energy is minimum. If we sketch a graph of energy versus displacement, we can draw it as this. Displacement and energy. First, I'm going to draw the graph of potential. Potential energy is maximum at amplitude and it's zero at center of motion. It is a smooth curve, but my goal is not a smooth curve. You should draw a smooth curve. This graph denotes the potential energy. Then we talk about the kinetic energy. We know that kinetic energy is minimum at amplitude and maximum at the maximum at the center of motion. Right? This curve denotes kinetic energy. We can get total mechanical energy by adding to this graph because total mechanical energy is potential energy plus kinetic energy. By adding this graph, we can this straight line like this. It proves that the total mechanic total mechanical energy of the simple harmonic motion is a constant. Total mechanical energy. In next video, we are going to talk about relative circular motion of simple harmonic motion.